Did you know that if you blow out a candle, you can immediately relight it without the match's flame ever touching the wick? Here's why. A candle is basically made up of two parts, a wick, which is usually braided cotton fibers, and wax. Now, wax comes in a variety of chemical forms, so we're going to look at one of the more common human-made waxes, paraffin. Paraffin is refined from crude oil. It's made of hydrocarbons, which are just long chains of hydrogen and carbon atoms. Hydrocarbons come in all shapes and sizes, and when they burn, they release a lot of energy. That makes them very useful as the fuels we use in our lives every day, like methane, butane, and propane, which are made up of short-chain hydrocarbons. Waxes are made up of many different long-chain hydrocarbons. Take, for example, hentriocontane. It's one of the many types of hydrocarbons found in paraffin, and it has 31 carbons and 64 hydrogens. While short-chain hydrocarbons are often gases or liquids at room temperature, waxes are solids because their long hydrocarbon chains become tangled up with each other at room temp. Now, although the wax's hydrocarbons are actually the fuel of the candle, I can try and light the wax of this candle on fire directly and the candle will not catch on fire. Here's why. When you light a candle's wick, the reaction begins. At the base of the wick, the flame is hot, over 500 degrees Celsius. This melts the solid wax into a liquid that the absorbent wick sucks up into the flame, where the hydrocarbons get so hot that they become gases. These gaseous hydrocarbons react with oxygen in the air to form carbon dioxide and water vapor, releasing energy in the form of heat and light. This reaction is called combustion. Let's try some experiments to see how this works in practice. So I'm going to blow out this candle, and you can actually see how flammable the wax vapor is. I can quickly relight the candle by holding a flame above the wick. And because the wax vapor is still highly combustible, the candle relights without the flame ever touching the wick. Now I'm going to do something else. I'm going to put a spoon over the flame. If I put it at just the tip of the flame, you can see all this black stuff sort of collected on the bottom of the spoon. This is called soot. It's just another name for carbon. What's happening here is that my spoon is half starving the reaction of oxygen. When there's not enough oxygen for the wax to burn completely, a slightly different reaction happens called incomplete combustion. One of the products of this incomplete combustion is carbon, or soot. If I lower the spoon towards the bottom of the flame, where it's the least hot, I'm interrupting the reaction in a different way. See this white stuff? That's not soot, it's actually unburnt wax. What's happening here is that the hot gaseous wax, instead of burning, collides with the cooler spoon, so the wax turns from a gas back into a solid and collects here. And finally, if we take our candle and cover it with a glass, it'll eventually burn out once the fire has consumed all of the available oxygen. You can't see the carbon dioxide that's produced from the combustion reaction, but you can see the water collecting here on the inside of the glass. And that is how a candle burns.